All right, so the notes for 6.1, we're going to talk about the greatest common factor and then factoring by grouping. So we did this whole thing where we had to multiply out our binomials and we we FOILed and we box methoded all of that. But now we're going to break it down to the starting point. So when we multiplied and stuff, that was the answer, that was the end. And now I'm going to give you the answer, and I want you to work backwards to find the factors. All right, so I've actually used 2 of our vocabulary words in the last, 30 seconds. But vocabulary for this lesson, we have a factor, and we talk about factoring, okay? So a factor is a number or expression that is multiplied by another number or expression to get a product, okay? So example, we have 3 and 4, they're factors of 12. And I know that because 3 times 4 is 12. And so if I said, what are other factors of 12? Okay, we know that we have 1 and 12, because 1 times 12 is 12. And then we also have 2 times 6. Okay. Sorry, move that over a little bit. All right, so factors are just 2 numbers that we multiply together to get another number. Okay. Factoring is the process of writing a number or algebraic expression as a product. So 2 things that we're going to multiply together. Okay. The first big thing that we're going to talk about is this idea of the greatest common factor. We're going to factor out the greatest common factor. Okay, so the greatest common factor is the largest monomial that divides each term. Okay, so we're looking for the biggest number that all coefficients can be divided by and each variable all terms have in common with the smallest exponent. Okay, so to find the greatest common factor, we're going to find the biggest number that all coefficients can be divided by. If the first number is negative, you need to factor out a negative. Okay, that's kind of a big deal. Your calculator, however, can find the greatest common factor for you. All right, so let me look at my calculator real quick. So we go math, then we go right arrow key to NUM, okay, and then we go to option 9. Okay, and option 9 is GCD. And I'll show you in an example how we're going to use that to help us figure out the greatest common factor. Okay, and that's going to tell us the number that we factor out, that we're going to divide all the coefficients by. Okay, step 2, we identify variables that all terms have in common and the smallest exponent. Okay. So that's how we find the variable. So to factor out our greatest common factor, once we find it, we're going to divide everything by it. Okay? And so our answer is going to look like this. Greatest common factor times whatever's left. Okay? And then there's some extra words here. Okay, so let's go ahead and look at just the guided practice. We're just going to jump right in. Okay, so we have 3x to the 5th plus 12x squared. So in my calculator, I went to math, number, NUM, sorry, and I'm going to go down to option 9, GCD. So when I hit enter, math, number 9, it gives me this. So I'm going to put the coefficients in separated by a comma. Okay, so I have 3, 12. And if I hit enter, it's going to tell me that the greatest common factor of both of them is 3. Okay, so I know I'm going to divide both of them by 3. And now I'm going to look at the x's because they both have x's in common, but now I need to find the one that has the smallest exponent. So the one with the smallest exponent is the squared. Okay, so I'm going to divide by 3x squared. Okay, does that make sense? Because that right there is our greatest common factor, and so that's going to go on the outside of the parentheses. 3x squared. Okay, so looking at our first term, we know that 3 divided by 3 is 1. X to the 5th divided by x squared, because we're dividing, we have to subtract exponents. So 5 minus 2 gives me x cubed. Plus 12 divided by 3 is 4. And then x squared minus 2 is just x. Well, x squared minus 2 is 0, so it actually cancels out. The x's cancel. And so that's what I'm left with. And that's my final answer. Okay. So now we're going to look at number 2. All right. Now the greatest common factor function here, I guess, I haven't figured out, I'll be honest, I haven't figured out how to use it in a way that is like 3 numbers. So I'm going to laugh if this works. But if I do 8, 16, and 20, it tells me I have an argument. So I'm going to go through to, yeah, I don't know how to do it with 3. Math number 9, and I'm going to do 8 and 16. So between 8 and 16, it's 8, but between 16 and 20, it's 4. All right, so is 8 divisible by 4? Yes. So I know I'm going to use 4 instead of 8. So my greatest common factor, we're going to start with 4. Now we're going to look at the variables. Okay, so we have our a's, and they all have an a in common, but we're going to look for the smallest variable, or I'm sorry, smallest exponent. And on our a's, the smallest exponent is a2. So I'm going to a squared as my exponent. And then I'm going to look at the b's, and we're going to look at the b values. And the smallest b value is squared. So this right here is actually what I'm going to divide everything by. Okay, so I'm going to divide this by 4, a squared, b squared. This by 4, a squared, squared. And this 4, a squared, b squared. So I already know my greatest common factor, so I'm going to go ahead and write that. So 4, a squared, b squared. I'm going to have parentheses for whatever goes inside there. Okay, so looking at the first term, 8 divided by 4 is 2. 3 minus 2 is 1. B squareds, they cancel out. So I'm going to move on to the next term. 16 divided by 4 is 4. A squared cancel out. 3 minus 2 is b. Move on to my next term. 20 divided by 4 is 5. 3 minus 2 is 1 for both of them, so I have a, b. So that's my final answer for number 2. Okay. So let's look at number 3. So if we're trying to find our greatest common factor for number 3, even if you're unsure and you go to math, oops, wrong one. that's calculus. Oops. 9, and I do 2 comma 9, 1. So the only number in theory that these two things share is the number 1. However, if the first number is negative, you need to factor out a negative. So because our first number is negative, we need to factor out a negative 1. So negative 2 divided by negative 1 is just a positive 2. And 9 divided by negative 1 is negative. So that would be my answer in this case. Okay. All right. So let's look at number 4. Still looking for our greatest common factor. So I'm going to go ahead and look at the numbers. So 3. Okay, so I'm going to 3. Look at your variables now. Do they have a variable in common? No. So because there's no variable in common, my greatest common factor is simply 3. So I'm going to divide everything by 3. Okay? So 3 divided by 3 is 1, so we just have an x here. You can put the 1 if you need to, but you don't have to. Minus 15 divided by 3 is 5y. There you go. Okay. Looking at number 5, greatest common factor. So is 5. Now we're going to look at the x's. All right, so this is an x cubed. This was an x squared. We're going to go with the smallest, x squared. So we'll put that on the outside, 5x squared. And we're going to divide by that. Okay. So when we divide by 5x squared, 15 divided by 5 is 3. And then we have x cubed over x squared, so 3 minus 2 is 1. Minus 5x squared divided by 5x squared. Anything divided by itself is just 1. Okay. Looking at number 6. Greatest common factor. So we're going to look at our numbers. 16 and negative 24. Oh, it won't work because I put the negative there. Okay, so these two share an 8. 24, oops. And 12, however, they share a 12. Okay, so let's look at 12 and 16. Four. Okay, so if I were to use 8, not every single one of these numbers is divisible by 8. So 12 isn't divisible by 8. If I use 12, 16 isn't divisible by 8. Or I'm sorry, by 12. But if I use 4, I can divide every single one of these numbers. Okay, so I know I'm going to have a 4. Now we're going to look at our variables. We have x, x, and x. So we know there's going to be an x in my greatest common factor. But we're looking for the smallest exponent. So we're going to go with 3. Which means we're dividing everything by 4x cubed. Okay. So looking, I might have to move my parentheses. 16 divided by 4 is 4. 5 minus 3 is 2, so we get x squared, minus 24 divided by 4 is 8. 4 minus 3 is just 1x. 12x cubed divided by 4x cubed. Well, the x cubed will cancel out, so we have 12 divided by 4 is a positive 3. So that is your final answer. Oops. Okay. I'm going to go ahead and let you guys work on 7 and 8 by yourselves to see if you can figure those out. And so what I'm going to do is I'm going to move on in the video to the ones on the back, factoring by grouping. Okay. So factoring out a greatest common factor is one way to factor a polynomial, or a trinomial, because there's 3 terms. The other way that we can factor a polynomial is this idea of factoring by grouping. So what we do is we group the first 2 terms together and the last 2 terms together. So we literally put parentheses around the first 2 terms and parentheses around the last 2 terms. And then we find the greatest common factor of the first set of parentheses, and then we'll find the second set of, or the second greatest common factor in the second set of parentheses. Okay, so when we group, we just 2 separate groups. We don't rearrange anything. We just boom, boom. Okay, we factor out that greatest common factor out of each pair or group of terms, and we know we did it right if whatever inside the parentheses matches. Okay, after we do all of this, that, and the other thing, okay, oh, I did say that we couldn't switch if we don't move them around. If we need to move them around, this is my bad, we only switch the middle 2. Okay, so the middle 2 terms are the only 2 that we would switch. Okay, so step number 2, write the factored form of the original polynomial as a product of boom and boom. Okay, so one set of parentheses will be the 2 greatest common factors that we factored out, and the other factor will be the matching set of parentheses. Okay, so let's just jump right in because it's kind of hard to explain that. Okay, so looking at example number 9, I'm going to split them up into 2 different colors because I think that'll help. So we're going to go boom, boom. So we have my red or my blue parentheses, boom, boom. A second set of parentheses. So looking at my first set of parentheses, the first thing I notice is that in the blue set, I can factor out an x. So it becomes x times y plus 3. Okay. In my second set of parentheses, I notice that this has a 2y and this is just a 6, so I can't factor out a y. But 2 is a factor of 6, so I can divide by 2. And when I divide by 2, I get y plus 3. And as long as these 2 sets of parentheses match, I know I'm on the right track. Okay, so to rewrite this as a polynomial, I'm going to take what's on the outside, and they become my first set of parentheses. And then I'm going to take what was on the inside, and it becomes my second set of parentheses. And so that's my final answer. Boom. Okay. Looking at number 10, I'm still going to stick with the same idea of blue and red. Looking at the blue set of parentheses, the first thing I notice is 2 and 5. I actually can't factor anything from 2 and 5, but they both share an x. Okay, so I know that I can divide both of these by x. Okay, so x will go on the outside. So 2x squared divided by x is 2x plus, the x's will cancel, so we have 5a. So let me cancel this out. All right, and in my red set of parentheses, again, I noticed that negatives, okay, so we have a negative here, which means I have to pull out a negative when I factor. 2 and 5, like before, they don't factor out, but I can factor a y out of both of them. So I'm going to pull out a y. So in both of these terms, when I factor out a y, the y's cancel, but because I'm factoring out a negative y, these signs are going to change. So it becomes a positive 2x plus 5a. All right, so here's my first parenthesis, x minus y, and here's my second one, 2x plus 5a. All right, looking at number 11, the first thing I notice is that if I keep this problem the way that it is, I cannot factor anything. So if I looked at that as my first factor, 3 and 10 don't share a factor at all, and 10 doesn't have an a or an x to factor out. If I kept it this way, same, can't factor anything out. But what I can do is flip the 15x and the negative 10. Okay, so when I flip all of that, all I'm going to do is just rewrite it. So we have 3ax plus 15x minus 10 minus 2a. Okay, so we still have blue, we still have red. Okay, so looking at my blue, in terms of coefficients, both of these are divisible by 3, and they both share an x. So 3x is on the outside, cancel, so I'm left with a, right? And then over here, the x's cancel, and I'm left with a plus 5. Looking at the red, the first number is a negative, so I have to pull out a negative sign, but they're both divisible by 2, or in this case, negative 2. So we get a negative, oh, I'm sorry, that should be a 2. It's my fault. Negative 2, so this should be a 5 plus a. Okay, 5 plus a and a plus 5 are the same things. So that's why we are able to still write it like this. 3x minus 2 and a plus 5. All right. So I'm going to do one more because this video is going a lot longer than I thought it would. Blue, red, 12 and 8 is 4, yes, 4, and then they both share an x, so 8 divided by 4 is 2, x squared divided by x is x, minus 3, those x's cancel. And then looking at the red one, we have 14 and 21, which off the top of my head should be 7. So we have a positive 7, 2x minus 3. So my final answer, put those in my new set of parentheses, 4x plus 7 times 2x minus 3. All right, you can do the other two that I didn't do, or you are welcome to get started on practice problems.